Hello guys, I'm Mohammed Nasir Bekani. I'm a bike technician. About a month ago, I was searching for how to test the different electronic parts of the ESA shocks. I didn't find so much information about them, so now I decided to show you how to test a complete test after different electronic parts on these ESA shocks. This is a BMW. What do we have here? A BMW K series S model rear shock with compression sensor, rebound sensor, and the DC motor for adjusting the preload of the spring. The tools we need here is multimeter, the most important one. This is scope for capturing the signal of the two-wire Hall effect sensor, two resistance which connect in series with each other for make the 12-volt battery voltage to 9 volt for the Hall effect sensor. 12-volt battery, and this is a DIY circuit to this is a pulse generator which generates two pulses with different phase for testing the compression and rebound sensor. Okay. Step one, we're gonna measure the resistance of the different parts. Turn on the multimeter and go for measuring the resistance. First thing, we're gonna test our props. Okay, it's 0.1 when we connect two props to each other. That's good. Let's start. And this is good. This connector is for the DC motor. First, we have 4 wires on this connector. On this special suspension, we have the side wires for the DC motor and the 2 wires in the middle of the connector for Hall effect sensor. So I'm gonna measure the resistance of the DC motor. The 2 side wires, and you can see the resistance is about 0.5, and the 2 Hall effect sensor with the DC motor, so we have 5 mega ohm, which is they have no continuity with each other. This is for my hand resistance. Look at that. See, my hand resistance is 3 mega ohm. If I connect the DC motor wire to the Hall effect sensor, there is no continuity. And the resistance of the 2 wire Hall effect sensor is 5.6 mega ohm. Okay. So for testing the Hall effect sensor, we're gonna go for measuring the diode test. We put the multimeter in diode test and connect the props to the wire. The sensor. Okay, in one direction we read 0.6, and then reverse direction we read 1.4. Remember this direction because when we're gonna test in a step 2, when we're gonna test and capture the waveforms of the Hall effect sensor, our connection would be like this. The power supply of the sensor will connect to the one that my red probe is connected to it now, and I read 1.4. Look at that again. And the ground of the power supply would be the wire which is connected now to the black probe. So this direction is important. This test was for the DC motor. Now I'm gonna get back to the ohm resistance and connect my probe lead to the rebound sensor connector. Let's see what we have here. Okay, 2-wire shows 44.3 ohm. When I connect it, this connector has 4-wire. 2 of them shows 44 ohm, and if I connect that wire to the 2 other wire, there is no continuity. So 2 by 2 up the 2 by 2 has 44 ohm resistance, and there is no continuity with each other. So it has 2 windings, and each winding has 44 resistance. This socket is, this connector is for compression sensor, and the resistance is the same as rebound sensor. See, 44.7. 44.7. Again, this sensor has 2 windings. Each winding is about 44 ohm resistance, and the windings are individual from each other, so there is no continuity between them. Okay, let's go for the step 2. The step 2 is we're gonna test exactly the sensors and electronic parts. First, we're gonna test the DC motor. The DC motor has a DC motor unit inside this box, which connect to the shaft, and that shaft will connect to the hydraulic jack. As you can see here, there is a bolt on it, which is for the oil in the hydraulic jack. The hydraulic jack will compress and decompress the S-spring, main S-spring. So it would adjust the S-spring preload. The maximum movement of this jack is about 1 centimeter, and there are some gears, I think plastic gears, I'm not opening it yet, but I see on some videos I think there are some plastic gears here inside this box, which the DC motors will connect to that shaft by those gears. After testing the ohm resistance of a DC motor, we're gonna connect the 2 wire of the DC motor, which are those wires on the side. We're gonna connect them to the battery voltage and see the hydraulic jack will compress the spring or not. If the spring is compressed fully, so we are expecting that it would decompress it. But you have two directions, compressing and decompressing. If you're gonna change the direction of the moving hydraulic jack, we have to change the polarity of the DC motor. So we have to change the connection of these leads. So if we put it on the, for example, this one to the positive side and this one to the negative side of the battery, we have to change them to see the change in the movement of that hydraulic jack. As unfortunately we have the battery here, but it's not fully charged, so I can't test the movement of hydraulic jack for you now in this video. But if you're gonna test the DC motor by the battery, make sure that your battery is fully charged. When I connect the leads to the battery, as this battery is not fully charged, after we connect that, the hydraulic jack won't move, and the battery voltage will drop to 7 volts. So we can't test it for now. I'm sorry. If you're gonna test it, make sure that you have a fully charged battery. After you make sure that the DC motor is working, and when you connect the DC motor to the battery, you just hear the sound of the motor, and the hydraulic jack is working properly. Just press and decompress. It's time to check the Hall effect sensor of the DC motor. So I'm just gonna explain it more. There is a shaft inside that DC motor, like for example my pen, but it is smaller than this pen. The pen has something like this, the notch. It has some notch on it. When it just turn, there is a sensor here. When it just turn in front of the sensor, the notch comes in front of the sensor. The sensor make pulse, a square wave. I will show you later on the scope. So that is necessary that when the DC motor is running, you get those pulses, because those pulses will show the ECU that the DC motor is running, and the ECU will count those pulses and set the correct position of that hydraulic jack for the preload setting. Let me show you on scope. Okay, the power supply for the Hall effect sensor is 9 volts. Let me say something in parentheses. I don't measure the exact power supply of the Hall effect sensor. I just read on software forums, which they measure that voltage and say the voltage is 9 volts. So we're gonna make the 9 volt for that Hall effect sensor. we're gonna make the 9 volts by 2 resistance. I don't know the exact number of the resistance. Let me measure it now. For I just calculate the numbers some days ago. One of them is 325. Another one is 100 ohm. And when we connect the 2 resistance to the battery and go for the voltage measuring. Okay, this is positive side of the battery. This is the negative pole of the battery. The battery voltage is 12.5. This is not a good battery because under the load it just drop voltage. But for now we have 12 volt battery, and the wire which is between those resistance have the voltage about 9 volts. So this would be this wire would be our positive power supply for the 2-wire Hall effect sensor. As I said, I think that I forgot which of them should connect to the positive side, so let me just try one more time. Yes, so this wire should connect to the 9 volt. Okay, and this wire should connect to the GND, but for having a safe test, I'm gonna use a resistance between the GND of the sensor and the GND of the battery. So I'm gonna use a wire which there is a resistance on it. So this wire is good. This is just forgot that resistance. I'm gonna connect that wire, that side of the wire, and to the negative of the sensor, and this side of that resistance to the GND, ground of the battery. Just tape them if you're gonna test it. I don't have that time for now. So forget this resistance. It's just for another test I'm using for now. So the ground of the sensor is going through the resistance and then goes to the GND of the battery. This resistance is for safety. Now the time for connecting the scope probe. Okay, the scope probe leads are connected. One of them, the red one, will connect to the GND. I'm sorry, before that, the GND of the sensor, and another one will go to the negative of the battery. It connects to the channel 1. We're gonna connect that to the channel 1. Lock the lead, prop, every just call it everything you want. Now we're gonna okay. There's two other wire, which if we connect them to the battery, the DC motor will activate. Okay, I turn on the computer. We have 8 channel on this scope. I'm gonna turn off the I'm gonna turn off all channels, just channel 1 turn on. So this is channel 1. Now you see we have voltage in here. So if I'm gonna show you the voltage, it would be, I think, 9 volts should be, except measure where to go, maximum. Okay, it is 3 volts. It is 3 volts because of the 3 volts. Our power supply for the Hall effect sensor is 9 volts. The power just goes into the Hall effect sensor and it comes out with 3 volts. Okay, I'm gonna choose 50 microseconds for horizontally zoom, and we are okay. We just need to connect the DC motor, the DC motor wires to the battery. Okay, the two, if you remember the two blue wires, and these colors are not important because I connect myself these leads and they're not OEM leads. When I connect that wire, the positive, okay, it just comes off, the positive wire to the DC motor, the DC motor starts running, and it is the Hall effect sensor should start making making some waveforms. Okay, let's see. Okay, we just lose connection to the oscilloscope. It connects again. Because of that, we didn't see the full waveform. Let me, okay, connected again. Again, I don't know why we didn't see anything. Let me check. Let me check again. Okay, I just reconnect my scope prop to another connection. The red one prop of the scope just connect to the power supply of the Hall effect sensor, which is 9 volts, and the ground side of the scope probe goes to the negative side of the GND side of the Hall effect sensor. So they connect exactly to the wires of the Hall effect sensor, the power side of the Hall effect sensor and the ground wire of the Hall effect sensor. So we're gonna now I'm gonna connect the DC motor, and when the DC motor is running, we should see some pulses from the Hall effect sensor. So let's see. Okay, as you see, I don't know, you hear the sound of the motor or not. The motor is not running smoothly because our power supply is not fully charged. When we connect the DC motor, again, let me connect it. We got some pulses. The high voltage of the pulse is 7.4, now 7.7, and the low voltage of this waveform is the minimum voltage is 4.3. So it's the 8 volt, the 9, the 7 volts just drops to the 4 volt and again get up. These square waves, the ECM count these square waves and set the exact spring preload adjustment by what you select. So now we know how the DC motor running and how the ECM knows that the exact position of that spring by counting those pulses. If we change the polarity again, we capture those pulses by the Hall effect sensor. So the DC motor and Hall effect sensor are checked, and in this ESA they work well. Let's go for testing the compression and rebound sensors. For testing the rebound and compression sensors, we need to generate two poles with different phase. For this, I make this DIY circuit. Let me show you. It has two mode key rocker switch. I mean, look at that, and two alligator for connecting to the battery, and 4 wire are the outputs wire for connecting to the sensor. Those sensors have 4 wire, 2 by 2. They have individual circuit. These two has 1 pulse, and these two has another pulse degree. So the inside of this board is an E555 pulse generator and DRV. This is the DRV port, and some This is a regulator and some capacitor and resistance. If you want to make this circuit, just mail me and send email for me. I will send you the diagram of the circuit. Okay. And if you have the IACV sensor tester, the process, your tester would build something like this. So it is an IACV sensor tester 2. Look at that. I make a connector for that sensor too. So if you have that tester, you can use it for these sensors too. If you don't have, you can make something like this. You can check these sensors and also IACV sensor too. I'm gonna show you the pulses which generate by this circuit on this scope. Let me show you. Okay, these two pulses waveforms are made by this circuit. The different phase between those pulses are 90-degree, and let me show you what's happening when we just apply that waveform to the sensor. Let me get back. Okay. Just the last thing I remember is that these pulses should should connect to each wiring of the sensors at the same time. This is very important that apply these pulses at the same time to that sensor. If you don't apply that pulses at the same time, the sensors will not work. And each pulse is for each winding. So, for example, the first winding is for this pulse, and the second winding should receive that pulse. And this is what's happening in real to that sensor. This sensor is exactly the same as that sensor. This is for IACV, and this is for compression adjustments on the ESA. So what's happening is this. The shaft will open or close the valve at the orifice of the oil behind the gas, nitrogen gas pressure. So let's see. If I apply the signals to the sensor, see the sensor is coming out. If I get reverse, get the pulses differently in different phase. I mean, this is so hard to explain you. But if we change those up and down on the waveforms, the movement of this sensor will change. Look at that. Okay. What we're gonna do now is we're gonna connect those wires to the ESA sensors, and we're gonna hear the voice, which something like that. It has a bzzz sound, and we're gonna apply the power to that and hear the voice. When after it just complete the movement and the valve is open completely or closed completely, the voice just end, and we won't hear anything. So we're gonna connect the wires to that and apply the power, and waiting for the sound to just the sound will end, and again change the direction and wait for the sounds to just shut off. I don't know, I can't remember the exact word to explaining what is inside my mind. Sorry for that. Let's check it. Okay, now I'm gonna put my microphone near to the sensor. I hope you can hear the sounds of the sensor when it's working and it stops working. Okay, I put it in the middle of the range uh, because we're gonna uh, install the shock on the bike. I just show you how the shaft is working, and when it just get the full movement, it stops the sounds and stop working. And again, the same test, the same procedure for testing this sensor too. It is exactly as the same to the compression sensor. فوق العاده است، قشنگه. میبرمش تا دیگه برای بستن راحت بشیم. میریم پایین. میره پایین. آره بیام بالا. Okay, the last words. Sorry for my English. I studied English many years ago, so I didn't remember some words, or maybe I pronounced some words incorrectly. And this was my first time video, which I make for YouTube. And sorry for that. I try my best to explain and to tell you guys the procedure. There's someone knocking on the door. Yes, goodbye.